Hello, my name's Kevin Monahan, and I would like to talk to you about the 2022 edition of Ports and Passes. The purpose of tide and current tables is to help you avoid situations like this and times like this. Timing is everything. Know when it's safe to go and when it isn't. Now, basic concepts. There are high water and there are low water, otherwise known as high tide and low tide. There are 2 high tides and 2 low tides per day. This is lower high water and higher high water, lower low water and higher low water. Chart datum. Chart datum or tidal datum is the plane from which tidal heights and charted depths are measured. In Canada, the tide very rarely drops below the chart datum. But in the United States, tidal datum is set a little bit higher, and so negative tides are actually fairly common. But remember, tidal predictions are just that. They're predictions. They're not absolute forecasts. In extreme cases, predictions may vary from the actual observed time by half an hour and half a meter in height, and extreme weather conditions can contribute to even greater differences. In December 20th of 2018, the pre-Christmas storm on Vancouver Island, widespread damage, lots of trees came down, sustained high storm force winds. Nearby at Friday Harbor, Washington, you can see that the recorded actual tides far exceeded the height of the predicted tides in the evening by approximately 2.5 feet or more. Now, in Ports and Passes, the 2022 edition, we have 5 new tide and current stations. You can see them here. They were all required to round out our coverage of the central coast of British Columbia. In addition to reorganizing the book, we have taken the secondary tables from the back of the book and extracted them and placed the information next to the reference tables that they're co-located with. We've got a new method for using the book and learning how to use the book. In this section, you will have a left-hand page, which is about tides, and a right-hand page about currents. In these maps, the colored areas are all referenced to a particular location, a particular reference port. For instance, in the Georgia Strait, on the left-hand panel, the areas colored yellow are all referenced to Point Atkinson, which means that the secondary tables give corrections from the Point Atkinson tides that can be used elsewhere in the yellow area. The same applies to currents, though you'll see that since currents are fairly weak in the Strait of Georgia, they're not tabulated for this area. Now, once you turn to the reference station for the particular area you're in, you will see a map page that gives you a better idea of the areas that are referenced to the reference station. And on the right-hand side, you will see a table of secondary stations with corrections. In addition, once you turn past the secondary stations, you will get into the actual tide tables for Point Atkinson or whatever tide table you're looking at. In these tide tables, you can see that the time column gives you the time of high and low water, and in the feet and meters column, we give the heights of the tide at those particular times. The 2nd of February, you can see that high water is at 7:10 a.m., 16.1 foot tide. At 12:44 p.m., it drops down to a 10.5 foot tide and then rises again to a 5:33 p.m. to a 13.8 foot tide. In the extreme right column, the heights are in metric. Now let's talk for a moment about reference stations and secondary stations. Reference stations have been studied for a significant period of time, usually at least 1 year. Secondary stations may only have been studied for a month or possibly less. So what we have is a far more correct and accurate reference station, and then the corrections that are applied to that to give us our estimates for secondary stations are reasonably good. In fact, the Canadian Hydrographic Service tells us that when applied to the reference station data, the corrections from the secondary tables provide reasonably accurate approximations for all navigational purposes. So let's take a look at the secondary stations for Point Atkinson, and let's focus on the height and times of tides at Lund. You can see here, this is the line for Lund in the secondary tide tables. And if we look at high water, and the time correction is +7 minutes. So Lund, high water at Lund is 7 minutes after Point Atkinson. The height of high water is 1.3 feet higher than at Point Atkinson. For low water occurs 9 minutes later than Point Atkinson, and the height of low water on a mean tide is 0.3 feet higher than Point Atkinson, and on a large tide, low water will be at the same height. So now we can go and take our information and put it into a table. These worksheets, these tables, are provided in Ports and Passes, and also they're available on the Ports and Passes website. So let's go to the tide tables and pull out the data from Point Atkinson for the day we're interested in this case, the 2nd of February. We take this information and we grab one of the worksheets. We're going to do the calculations for Lund, February 2nd, 2022, and the reference station is Point Atkinson. So we extract the information from Point Atkinson and we place it on the correct line for the reference station columns. We then extract from the secondary tables the corrections, the time difference and the height difference for Lund. And then we just simply do the math. And this here is our tide predictions for Lund for the day. Now, in the United States, instead of giving us a correction that's added or subtracted from the height of the tide at the reference station, sometimes we're given height ratios. So this is how we work with that. Let's look at a reference station of Point Townsend and the secondary station Point Roberts. Let's grab the information for the 2nd of February, Port Townsend, from the tide tables, and let's grab the information for the secondary corrections for Point Roberts. Now, you will notice that the time difference between Point Roberts and Port Townsend is actually over an hour on both high water and low water. In fact, low water, it's over an hour and a half. So these time differences can be fairly significant. It is worth doing these calculations. Then we go to the height ratio. For high water, the height ratio for Point Roberts is 1.14, which means we multiply the height at Port Townsend by 1.14 to get the height at Point Roberts. The same for low water, the height ratio is 1.08. Then we simply go to our worksheet for the 2nd of February, 2022, and we put in the information from Port Townsend, high water, low water, etc. We then put in the corrections and note that the height ratio, it is a multiplication this time, not an addition. Then we simply do the math again. So we add 1 hour and 1 minute to 6:09 a.m. and we multiply 9.6 feet by 1.14, and the answer is here. And this is your daily tide table for Point Roberts. Now we can also estimate intermediate tidal heights. This isn't exact, but it's a good estimate. And it's based on the principle that in the first hour of the tide rises 1/12 of the total amount. In the second hour, it rises 2/12. In the third hour, it rises 3/12. And that means at the end of the third hour, we've risen half the height. Then the speed drops off. In the the fourth hour, the tide rises or falls by 3/12 of the range. In the fifth hour, 2/12, and during the sixth hour, 1/12 of the range. We simply take these percentages and multiply by the difference between high and low water, and we can get an approximate tidal height for those hours. Now, this is assuming that the tide takes place over 6 hours. If it's a 5-hour tide or a 7-hour tide, we will have to modify our results accordingly. Let's now look at current tables. They're a little bit different than tide tables. Here is the current table for Gillard Passage, and here we can see the map for Gillard Passage. Gillard Passage is in Desolation Sound as you move up towards the Broughtons. Gillard Passage itself has fairly strong currents. Let's take a look. We can see here on the daily tables, and again, these are for the 2nd of February, that at 2:07 a.m., the current is flooding. That's what the plus sign means, is that the current is flooding at 11.3 knots. Then at 5:35 a.m., the current is slack, and this is what we call turn to ebb. At 8:41 a.m., the ebb is at maximum, and it's ebbing at 7.9 knots. And there's a negative sign, a minus sign in front of the 7.9 indicates it's an ebb current. So we can see that there are some pretty strong currents here in Gillard Passage. Now, we go to the secondary current tables, and for Gillard Passage, there are only 2 secondary stations. Let's look at Dent Rapids. Dent Rapids turns to flood 15 minutes before Gillard Passage, and it turns to ebb 25 minutes before Gillard Passage. The maximum rate is 11 knots on the flood and 9.5 knots on the ebb. But in addition, they provide us with a percent reference rate, meaning that whatever the flood maximum is at Gillard Passage in Dent Rapids, the maximum speed is 90% of that. On the ebb, it's 100% of the speed at Dent Rapids. Again, we go to our worksheet. We're looking at Dent Rapids. We're looking at Gillard Passage as the reference station on the 2nd of February 2022. And we simply enter the information from Gillard Passage in the reference station columns. And here they are. Now we have to be careful to make sure that we match the turn to flood line with the actual flood. So 10:41 p.m. of the day before is the turn to flood. Maximum flood at 2:07 a.m. and the speed 9.5 knots. Okay, we've got that laid out correctly. Now let's enter our corrections, and you will notice that Dent Rapids did not give us any corrections for the time of the maximum speed. But we do have the time of the turn, and we do have the speed ratio. So when we add or subtract the correction for the turn to flood or turn to ebb, and we multiply by the speed ratios, then we have now got our values for Dent Rapids at the secondary station. And you can see that we still have very strong currents at certain times of day. But these times here are the slacks. This is when we should go through. We don't have a time for the time of maximum speed, but we do have an indication of what the maximum speed is. Now, some secondary stations are referenced to a tide station. For instance, Malibu Rapids is referenced to Point Atkinson. So here, all we have is a correction for the time of the turn, the time of slack water. And for Malibu Rapids, the time of slack water is 35 minutes after low water at Point Atkinson. The time of the turn to ebb or high water slack is 25 minutes after high water at Point Atkinson. And the maximum current speeds are 9 knots in either direction. So what we now do is, again, we go and get the information from Point Atkinson for the appropriate date. So having obtained our data from Point Atkinson, we simply enter it into the worksheet for current calculations. Malibu Rapids, Point Atkinson reference station, date, and we simply enter the time of low water, high water at Point Atkinson. Remember, the turn to ebb occurs at high water slack and turn to flood occurs at low water slack. We then enter our corrections from the secondary tables, and here they are, and we do the math. This then gives us the time of slack water at Malibu Rapids. Now, we can't get a lot more information than this because it's referenced to a tide table and not to a current table. You'll find this is fairly common in the north coast of British Columbia. We can also estimate intermediate current speeds. We know that after the first hour, generally the speed of the current is up to 50% of its maximum. At the end of the second hour of the current, it's up to 90%. And after the third hour, it's 100%. And then it drops back down 90%, 50%. And finally, at the end of the sixth hour, back to slack. Now, if the duration of the current is more or less than 6 hours, you've got to adjust the estimate accordingly. These are not highly accurate. There are individual characteristics to every tidal rapids, and some of them reach maximum much sooner than this. This is one of the reasons why you should always try to go through the significant tidal rapids as slack water. So why do we go through all of this? Well, for one thing, you want to be accurate. We use a paper-based system, even though it's far more complex than using a tide app, because we don't have any guarantees about the accuracy of the tide apps. The measure of the quality of the tidal data is the quality of its source. So do you know where the data comes from in your tidal application? Ports and Passes uses data from official sources only. In other words, the people that do the quality control on the data are the people that did the surveys. If you get tide and current data from unknown sources, you don't know where it came from. It may have been calculated from obsolete constituents. A constituent is the algorithm that's used to calculate and predict tides. Over time, hydrographic agencies update their constituents, and therefore they're more accurate than the older constituents. And if you have a tide app that isn't regularly updated, then it will drift further and further away from the predictions made by the official agencies. Tide and current apps are useful for approximate times of tide and current, but when it's important to get it right, use data from official sources only. Ports and Passes is available at marinas, chandleries throughout the Pacific Northwest, and in Canada from portsandpasses.com, and in the US from wagonerguidebooks.com. You can also obtain the Ports and Passes ebook. It's available from Amazon.com and Amazon.ca, and it is in 3 volumes. It's in Kindle format, but Amazon makes available a free Kindle reader application that you can download, and it will turn your tablet or your smartphone into an ebook reader. I would like to thank you all very much for taking the time to listen to me today, and I wish you safe and happy cruising. Thank you very much. Goodbye.